So our next question, question number 20. For most brittle materials, generally ultimate strength in compression is much larger than ultimate strength in tension because, okay, now suppose we have taken a concrete cube, okay, concrete cube, and this concrete cube is a brittle material. Now I am going to perform compression test on this cube. So ultimate strength, you have to check ultimate strength, and suppose this cube, and on that cube you have to perform tensile strength, okay, you have to perform tension test. So when you are performing compression test on that brittle material, definitely ultimate strength is much larger, ultimate strength is much larger than the tension due to of flaws such as microscopic cracks or cavities. Okay. तर बघा हे please remember that when we are going to prepare that cubes, at that time some voids or cracks are present. So due to this, ultimate strength in compression is more due to in tension. So correct option is A. Correct option is A. Then next question number 21. Which of the following is primarily responsible for the toughness of steel? This is the basic question. Now you tell me. Correct answer is
option C.
option C. Good. Correct answer. Please remember that this is too much basic question. Which of the following is primarily responsible for toughness of steel? So manganese is responsible for toughness of steel. So option C is correct answer. Then question number 22. The modulus of elasticity of high tensile steel is, okay, see, modulus of elasticity of high tensile steel is smaller than that of mild steel, equal to that of mild steel, larger that of mild steel, or equal to that of aluminum.
C.
Larger by
Option B.
equal to that of mild steel.
I think it is
Please remember that modulus of elasticity is same, do not changes. Okay. So correct answer is option B, equals to that of mild steel, equals to that of mild steel. Then question number 23. The stress strain curve for an ideally plastic material is ideally plastic material.
option D.
Option D. Yes, please. Anyone guesses?
A option.
Option
A.
Yes, option बरोबर आहे.
कुठला A? What is asked? Plastic material. Ideally plastic. Ideally plastic
C.
means, yes, good, correct answer. Ideally plastic means in this figure there is no any elastic curve. So this linear graph indicates here elastic limit is present because of stress is directly proportional to strain due to this diagram. Here also this is present, here also present, but in figure C only straight line is present. That is, here there is no stress is directly proportional to strain. So correct option is option C. For ideally plastic material only straight line is present. This is elastoplastic. Okay. And then last question 24. One of the following favors brittle fracture in a ductile material. Elevated temperature, slow rate of straining, presence of notch, circular cross section. Correct answer is D, circular cross section. Circular cross section. Then we will see next type of questions. Match list or match the pairs. Okay. So first, list one and list second. So in that creep. So now you choose from these four and tell me creep means amenability to go through changes of shape without rupture, susceptibility to deform with time under sustained loading, ultimate tensile strength, susceptibility to fail sudden without warning. Which one is correct for creep?
Second.
Second, because of deformation with time under sustained loading. So for A, second is correct. Then B, tenacity. Okay. Or we will take simple or easier first. Brittleness. So choose for brittleness.
1.
1.
4. 4.
Please read sentences carefully. 4 is correct answer.
Option 4.
Susceptibility to fail sudden without warning. Okay, so brittle material fails without giving indication or without giving warning. So brittleness is correct for 4. Then we will see for ductility. Ductility means
Option 8.
1. Okay, so ability to go through changes of shape without rupture. That means ability to drawn into thin wires without rupture. And for B, C option is correct. Now we will choose correct option. Okay, so I think 4. Okay, 4. After that, no, first is 2. I will correct here.
2,
For
1, 3, 4. Option D.
2,
Option B.
D.
2, then
2, 3,
3,
1, 4.
1,
3.
and 4.
B.
Option B is correct answer. So likewise, you have to solve match the pairs or match list questions. Then second question, match list first with second and choose correct answer. Okay, choose correct answer. So list 1, inelastic material, B, rigid plastic material, ductile material, and brittle material. Okay. So for A, inelastic material.
Option B.
Option C, strain is not recovered after unloading. Okay, inelastic material. Inelastic means plastic material. So strain is not recovered after unloading. That means does not regain its original shape and size after removal of loading. So for A, third option. Okay, for A, third. Then rigid plastic material. Rigid plastic material.
4 येते मॅम.
4.
4.
Strain is 0 up to a stress level and then stress remains constant. So for B, 4 is correct. Then for C, ductile material.
No plastic zone. 1. 1.
No, how it is possible? Please remember stress strain curve.
Larger.
Here in
2.
stress strain curve, in stress strain curve, elastic portion is limited, but plastic is unlimited. See here, up to this point only elastic limit, and after that, this is plastic. So ductile material is large plastic zone, and last for brittle material, no plastic zone. See here, for brittle material, stress strain curve is likewise. Okay, so plastic zone is not present for brittle, and for ductile material, large plastic zone. Now, tell me correct answer by sequence wise.
Option A.
A.
Option A is correct answer. Please remember these basic tricks. For ductile material, plastic zone is maximum, and for brittle material, there is no plastic zone because of material is failure suddenly. So plastic zone is not occurred. Okay. Okay. Likewise, this remaining match of pairs you solve, I will provide materials. Okay. After that, next second point, elastic constants and their relationships. Okay. Now we will continue this point, elastic constants and their relationships. So first, Young's modulus. Young's modulus is denoted by using E letter, and Young's modulus is the ratio of direct stress to direct strain. It is the ratio of direct stress to direct strain. So E, which is equal to sigma upon epsilon. This is most important point. Young's modulus for different materials. Please remember, for steel near about 200 GPa, for aluminium near about 70 GPa, for brass near about 100 GPa, for bronze 80 GPa, for copper 120 GPa, and for diamond 1200 GPa. So Young's modulus means direct strain. Okay. After that, next, second elastic constant is modulus of rigidity. And this modulus of rigidity is denoted by using C, N, or G. C, N, or G. And modulus of rigidity nothing but shear stress to shear strain. Shear stress to shear strain. So C or G or N, which is equal to tau upon epsilon. Then next, third elastic constant is bulk modulus, and it is denoted by using K. Bulk modulus is K. So when a body is subjected to like and equal direct stresses along three mutually perpendicular directions, the ratio of this direct stress to corresponding volumetric strain is called as bulk modulus. See here, this is a plane. On that plane, three directional forces are applied. Here, one, this is second, and this is third. That is horizontal, vertical, and inclined. So the ratio of direct stress to volumetric strain is called as bulk modulus, and it is denoted by using K. The next, lateral strain. Lateral strain is denoted by using, or lateral strain means when a structure is subjected to axial load besides the strain in axial direction, there will be lateral strain of opposite nature in all directions at right angles. Already you know that, lateral and longitudinal. Suppose this is a rod and I am going to apply load on that rod, and after application of load, this deformation takes place. This strain is lateral strain or longitudinal strain. And suppose this is another second example. Now I am going to apply load here. Suppose this is figure A and this is figure B. Now you tell me from both figures which strain is lateral strain.
A.
A. Here dimension changes with respect to diameter, then this is lateral. And if dimension changes with respect to length or longitudinal, this is called as longitudinal. Then next, Poisson's ratio. The next point is Poisson's ratio. Poisson's ratio is denoted by using mu. Poisson's ratio is denoted by using mu. It is the ratio of lateral strain to linear or longitudinal strain. Okay, and the range of Poisson's ratio is 0.0 to 0.5 for engineering materials. Okay, so mu is lateral strain to linear strain. See here, the maximum possible value of Poisson's ratio is 0.5 for an ideal elastic incompressible material whose volumetric strain is 0. Okay, and here some values are given. Cork 0. For cork, Poisson's ratio is 0. For concrete, 0.1 to 0.2. Cast iron, 0.2 to 0.3. For aluminium, 0.33. For gold, 0.45. For glass, 0.2 to 0.27. For steel, 0.27 to 0.3. Brass, 0.34. Gold, 0.44. Incompressible material, clay, paraffin, and rubber is 0.5. So please remember that the maximum possible value of Poisson's ratio is 0.5, and Poisson's ratio lies between 0 to 0.5. Okay, 0 to 0.5. Please remember this question, because of 100% one question is going to ask on your GATE examination or any other competitive examination. Okay. Then next is sixth property or six properties, relation between elastic constant, EGK. Already we know that relations. So here relations are given, E which is equal to 2G 1 plus mu, E which is equal to 3K 1 minus 2 mu, E which is equal to 9K G divided by 3K plus C. These relations already you know that. Okay. Then number of elastic constant. Isotropic materials, 2 constants. For orthotropic material, 9 constant, and for anisotropic materials, 21 constants. Please remember these numbers, numbers of elastic constant. For isotropic materials, 2 constants. Okay, for isotropic materials, 2 constants. For isotopic materials, 2 constant. Orthotropic material, 9 constants, and anisotropic material, 21 constants. Okay. Now theory part is over, so we will see questions in next lecture, or some 1 to 2 questions we will take. First question, the independent number of elastic constant for a completely isotropic material. How many constants for isotropic material?
2.
2 constants. So answer is, for non-dilatant material, the maximum value of Poisson's ratio is
0.5.
maximum value of
0.5.
0.5. Okay. So we will continue remaining questions in next lecture.